Hi there, this is Bill Punch at Michigan State University. This is another video on the topic, the practice of computing using Python, CSE 231. We want to do one last coverage of some issues that have to do with mutable objects such as lists so that we make sure we finally have this down pat. Let's go ahead and get started. So here's a little experiment, and we're going to use a new operator in this experiment called the is operator. The is operator is similar to the equal operator but more restrictive. So we know that the double equal operator, when it applies to two sequences, will come back true if those two sequences have the same elements in exactly the same order. That's what we know about sequences. The is operator returns true on two sequences as a measure of sameness. They are two sequences, two names that are referred to a particular sequence come up true if they refer to exactly the same object. So we can have two separate objects that are equal, but two variables are true under the is operator if they make reference to exactly the same object. And I want to look at some of those things and see how they affect us. Here's an example sequence. I have L1 to an object 1, 2, 3 and L2 to an object 1, 2, 3. These are two different objects that have the same values, and I'm going to print are they equal and are they is, which I know is a strange phrase, but there you go. And then subsequently underneath I want to say, well, I'm going to change L1 and have it point to L2 and make the same measure. Let's see what we get. So L1 and L2 are equal in the first situation, so this came back true, but they're not is, they don't point to the same object. But subsequently, when I said L1 is assigned the value of L2, not only are they equal, but they're the same. And if you were to look at how that went, here's a picture. So when we started out, this was our situation. L1 had an object and L2 had an object. They had the same contents but different objects. When we did the subsequent assignment and we said L1 equals L2, now both L1 and L2 point to the same object, right? And this object is released to be garbage collected. So they respond to the is operator, they're the same. If I said, A points to 1, 2, 3 and B points to A, that is they point to the same object, do the same measures, are they equal, are they is, change one of the values in A by index assignment and print B, we should see that they have the same changes, right? So A originally had 1, 2, 3, now it has 1, 2, 5, and when I updated it from A, the reflection is that it's the same now in B. Here's a picture of that situation. They both point to the same object. We update that last guy. Whether we report it through A or through B, we're going to see 1, 2, 5. Copying helps us get around that to some extent. We make an object 1, 2, 3 in A, and then we make a copy of A and assign it to B, making a new object, print out whether they're equal, whether there is, change the object in B, see if it affects A. A and B are equal, they have the same elements, but they are not is, they point to two separate objects. If I changed B, I don't change A. And if we look at that picture, here it is. A and B point to two separate objects, maybe with the same values. Because we made a copy, we changed the copy. The copy reflects the change, but not the actual value in A. That looks really good, except for here is a really tricky kind of example that shows us that the copying that we just did doesn't really solve the problem. Make a list A with 1, 2, 3, and then inside a bigger list called L, we have first element X. The second element is this A list up here, third element Y. And we print it. We make a copy of L, put it in M, print the same things. Are they equal? Are they is? Append something to the end of A, see what happens. When we do the evaluation, we print it, we get X, the list 1, 2, 3 from A, and Y. It's true that they're equal, it's false that they point to the same object, but when I changed the value of A, it's reflected in both L and M. What happened? This is what happened. when we did the copy, right, we only copy the top level values in each one. And so there's an X and there's a Y. And then the top level value is a reference to another object, A, and the element that's copied is that reference. Now both of these L and M point to the same referenced object, and if I append 4 to the end, we see that change in both L and in M. So the bottom line that we have to remember is copy moves elements directly, whether they are objects or whether they are references to objects. How do I get around that? There is a special method called deep copy that, if it encounters a reference, creates a new object. Here's an example of that. We import the copy package. We make A, we make list L with A inside it, and then we make a deep copy of L. When the deep copy encounters this reference to A, it makes a new object. Let's take a look at that. So they are equal, they are not the same, and that first element is, or that second element, that reference is different, and the change in one is not reflected in the other, and this is what it looks like if we were to draw the picture. When we make a deep copy and it encounters this reference, it makes a brand new object and makes a reference to that object so that we can avoid the issue. This is great as long as there are not a lot of things to copy. If there are a lot of things to copy, deep copy can be kind of expensive. Remember, this is only a problem for mutables because only mutables allow us to make a change in place, and if it's an immutable object, we can never change it in place. So if we were to apply the same stuff to, say, a string, we cannot change the string in place. It never comes up. Here's a picture of that. Right? When we do the replace generates a new string object. Doesn't affect the other object.